Hello, welcome to this video. So today again we're gonna talk things more physics related. This time we're gonna talk about polar coordinates. So usually when you have a vector and you want to represent it mathematically in some sense, you write it as the vector r is some distance x along the x-axis. So this is x, and this is y. So some distance along the x-axis. So x hat plus some distance y along the y-axis. So y hat. And x hat, y hat represent the base vectors and the directions x and y. So this is x hat. This is y hat. And these are vectors which point at the positive direction of any axis accordingly. X hat on the x-axis, y hat on the y-axis, and are of length 1. And then we use those, and then using those, we can describe any vector we want on the plane. And these, for most problems, these are x hat and y hat, sometimes z hat. These are usually all the ones you need. But sometimes you have a problem that's talking about circular motion. So let's say you have some rope attached to a ball, and then that ball is spinning at an angle of velocity omega, and we want to solve, and let's say it's constant, and we want to solve for the exact position of the ball, ignoring gravity, and sometimes even with gravity. It's a bit of a headache to do it with x hat and y hat. So for these kinds of problems, we have polar coordinates. Polar coordinates, instead of looking along the x-axis and y-axis, they represent the vector the sort of obvious way to represent a vector. Its length and its angle. So r is the length of the vector, theta is the angle the vector makes with the positive direction of the x-axis. And if we want to have any coordinates, we need to have certain base vectors for them. And our base vectors will be r hat in the direction of r, and then perpendicular to it, there will be a perpendicular and counterclockwise. In the counterclockwise direction will be theta hat. And these kinds of base vectors, depending on where your vector is, can change. So x hat and y hat don't change. Wherever you put your vector, they will stay the same, as long as you stay with the same coordinate system. But in polar coordinates, even if you stay with the same x and y, r hat and theta hat do change based on the angle that the vector r makes with the x-axis. So if r was like here, then r hat and theta hat would be in different directions than where they are here. And of course, this is all theoretical. If we want to actually use this, we need to find proper equations and formulas for r hat and theta hat in terms of x hat and y hat. So essentially, first of all, for r hat, what this is essentially, we have this angle theta, and because it's a base vector, we know this length is 1, and we know, let's call this y prime and x prime. Now we know that Now we know that it's the case that r hat is x prime x hat plus y prime y hat, because this is x, because this is in direction of x hat and this is the direction of y hat. So, but now we can do simple trigonometry in order to find out what is x hat, and y hat. So notice y prime over 1 is, by definition, sine theta. Y prime over 1 is y prime, which is sine theta. Sine theta is the sine of this angle. And now similarly, we'll have x prime over 1, which is x prime equal cosine of this angle, which is cosine theta. Meaning that now our base vector, r hat, is cosine theta x hat plus sine theta y hat. And now, we'll also have to find a vector for a formula for theta hat. So I'll let you try to figure out, based on this area here, why this angle is theta. It's only like 2 steps. It's not that hard. But anyhow, now we'll have this. Now we have this, and now I'll call this y double prime and x double prime. And then again, because theta hat is a base vector, this is 1, this is a 90-degree angle, this is theta. And now this time, theta hat is, instead of, so now theta hat, because now our x ends in the, turned into the negative direction, this time we have that theta hat is negative x double prime x hat, but this is the positive direction, so this is regular y double prime y hat. And now again, simple trigonometry to figure out that x double prime is sine theta, y double prime is cosine theta. Meaning that now theta hat, our formula for it, is negative sine theta x hat plus cosine theta y hat. So these are our 2 formulas for r hat and theta hat. Now, so let's now understand how we write our vector r using one of these or both of these. So notice we actually only need to use r hat to describe our vector r, because theta hat, it points in the perpendicular direction of our vector r. And now, like we said, that this entire thing can be described as x hat, because the length is x and this direction is x hat. We can say our vector r is just r, which is the length, multiplied by r hat, which is the base vector in the direction of r. And this describes the motion of the particle. Let's say we're talking about a particle, this describes its motion. But now, of course, it can't be that simple. And if we want this to actually be useful, if we're talking about position, the vector r, we also need to talk about velocity, and acceleration using polar coordinates for them to actually be useful. So let's quickly clean up the board a bit, and then we'll talk about that. Okay, so we found the position. Now we want to find, for polar coordinates to be actually useful, we want to find our velocity, so r dot, and the acceleration, r dot dot, double dot. This now won't be as simple as just taking the derivative. Well, it is, but the derivative won't be as simple as always. Because usually x hat and y hat are constants that we can take out when we're calculating the derivative, and we get a nice neat formula. This time it's not the case here, because in a vector r, when we change it, not only does the length change, but because its angle changes, its base vector also changes. So both of these are a function of time. When we're moving it as a function of time, r and r hat are both functions of time. And because we don't want in our formula to have the derivative of a base vector, we need to find formulas for these using r hat and theta hat, so that we don't need to have a headache every time we encounter a derivative of a base vector. So let's recall that our vector r is cosine theta x hat plus sine theta y hat. This is r hat, and theta hat is negative sine theta hat x hat plus cosine theta y hat. So now let's talk about the derivative of each one of these. So r hat dot is, well, now we are talking about Cartesian coordinates, so this time it will be nice. So it's the derivative of cosine theta times x hat plus the derivative of sine theta times y hat. So the derivative of cosine is sine, but remember, we're differentiating with respect to time, not to the angle. Meaning that we have to multiply by the derivative of the angle, because the angle can also change with time. So this is going to be theta dot times. So the derivative of cosine is negative sine. It's negative sine theta x hat. And the derivative of sine is cosine. So plus cosine theta y hat. Does this remind you of anything? Of course, this thing is just our formula for theta hat. Meaning that we can now write this with polar coordinates. That this is theta dot theta hat. Okay, now we will do a similar thing for theta hat. So theta hat dot is, again, we'll take the derivative. We do the derivative of our angle, which don't have a nice formula for, it's just theta dot. It depends on the problem. And then the derivative of each one of these. So the derivative of negative sine is negative cosine. So negative cosine theta x hat. And the derivative of cosine is negative sine. So negative sine theta y hat. Does this remind you of anything? Yes. This time it's not r hat. This time it's not like here. When it's the other base vector, it's negative the other base vector. So this is negative r hat. And multiplied by theta dot, this is negative theta dot r hat. These are the formulas for the derivatives of base vectors. Now we can finally get what is the velocity And I'll leave the annoying work for you to do at home for the acceleration. So let's do this. So the vector r dot. So we're taking the derivative with respect to time of a product of functions that are with respect to time. Meaning this is the derivative of r times r hat plus r times the derivative of r hat, aka so this is going to be r dot r hat plus r hat dot. Now for r dot again depends on the problem, don't have a formula for it, so this stays r dot r hat. But for r hat dot, we do have a formula in polar coordinates. It's theta dot theta hat. So this is going to be, so now we'll just replace r hat dot for the formula we got for it, theta dot theta hat, and we get that this is plus r theta dot theta. And this is our formula for velocity with respect to time. And we got a formula for r dot for the velocity, and I'll leave all the dirty work for you to do at home to find r double dot, the vector r, because now we have a product of two functions plus a product of three functions, and we have to use both of these. It's a tiny nightmare, and if I remember correctly, this is the formula. Whether you look up on the internet or actually power through and take this derivative painfully yourself, this is the result you should get. Don't judge me if it's a bit wrong, but if it's a bit wrong, it has like a tiny mistake, but we can. Assuming you did actually do the derivative, this is the result you should get, and we can supposedly check it off. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.